Okay, so let's think about solve x to the power 2 plus 1 is equal to 0 for x, right? Now what you do is x squared is equal to minus 1, then x is equal to plus or minus 1 square root. Now minus 1 square root is I, so this is going to be plus I or minus I, right? Okay, so that you know. Okay. Now, if you think about these values over here, these are the solutions, right? X values, for example, these are X values. But you have to understand, these are not numbers. This is not like 1.1 minus 2 or something like that. If you have these kind of numbers, you typically use Cartesian. Put the points down. But these are not XY numbers. Because of that, we cannot use or we cannot represent this in Cartesian plane. Because of that, we need to get another system. We need another system to represent it. And that system is called Argand diagram. Simple. So, what is the difference between this? Okay, I'll tell you that. Cartesian is X and Y. Argand diagram is like this. Argand diagram, x-axis is real axis. This is imaginary axis. It's the Argand diagram. Simple. So, example. If you have Z, so complex numbers we usually define as Z. We don't. It's okay to put X here, but X is used for Cartesian, right? See, suppose Z is equal to 1 plus 2y. Now it's a complex number. You have a real part and you have the imaginary part. Combination of those two is a complex number. That's the definition. Now you need to plot it, right? So let's see. If you need to plot this one, this is your X value, this is your Y value. This is in the shape of X plus IY. This is the shape of X plus IY. X is the real value, and I told you, remember, X is real, Y is real. However, IY is imaginary. Yeah? So X is the real one, which I'm going to represent here, and imaginary part here. So now, X value is 1, so it's here, 1. Okay, so X is equal to 1 here. Now, this is imaginary. Imaginary is this 2i part. However, how much is the length in that direction is 2. This is the point. So this Z means this. Z means this line. This is the starting point. This is the end point. Then you will understand. This is so simple. You will understand. If you need to find the length of this guy, since this is 1 and this is 2, right? It is Pythagoras. No? So that's going to be 1 square plus 2 squared square root. I think I'm right. 5 square root. No? So what is the length? 5 square root. So without drawing this, now we'll do this. If you have Z is equal to 2 plus 2y, for example, right? How much is the length? 2 squared plus 2 squared square root. That you might have seen a lot of times I'm doing it. So that is called actually Z mod. Z mod means this distance.
So then for that question, z mod is root 5?
Yeah.
Okay.
Yeah, for this question, yeah, this is z mod.
Okay.
For here, it's again like what? 4, 4, 8, 8 square root. That's z mod. Actually, that's the radius type of thing.
Yeah.
Hypotenuse, right? Yeah. So in general, z is equal to x plus iy. So z mod, you write x squared plus y squared square root. Now, while you are doing this, you understand that, but at the same time, you have to understand you have to visualize that in the Argand diagram as well. Okay, this is what I'm looking at. That's important. Okay. Now, if you want to plot x and y, right? Look at this. This is real. This is imaginary. Right? If you want to plot x and y, this x and y is everywhere. That can be here, that can be here, that can be here, that can anywhere. That we have to understand. But if you define a complex number like this, it is not everywhere. Why? Because 1 and 2 precisely given to you. So this is the point here, exactly. You can't change it. Right? But here, any can be here, or can be here. Right? So for simplicity, I'm going to take this point over here. And this coordinate I'm going to take x and y. You can take any point. Then this is the complex number, right? What is the distance here? Same one. Now, next one. Next one. Next one. Think about this point over here. So this is like, what do you call it? Mirror image of this point about x-axis. So you think about this. And then this also a complex number, right? Why? Because it's a complex plane.
Yeah.
This is called complex plane, okay? Argand diagram. This quadrant, this quadrant, this quadrant, this quadrant, they are the part of complex plane. Now, what is this coordinate here? X comma minus y, ne?
Yeah.
Right? That mirror image, this mirror image is called, this is called conjugate of z. Conjugate of c. So that is given by c bar. Conjugate of c.
Yeah.
Right? Okay, and you know conjugates, right? Like, for example, when you have a question like this, square root 2 minus 1, when you're in grade 8, rationalize the denominator. What you do? Both sides you multiply by this, right?
Yeah.
When you're doing this, what do you call this term? We are introducing the conjugate. Conjugate is a universal term where you change the signs here like this. That is called conjugate. So it doesn't matter where you're using it. So here the same. Okay, you got it. Now, example. Example. Suppose you have z is equal to 1 plus 3i. Now you have to visualize. Okay, 1 is here, 3 is there. Okay, first quadrant this. Now if you want to find the mod, yes, you can do that. Now you need to find conjugate of that. Okay, what is the conjugate now? What is the conjugate now? Conjugate you can visualize. Okay, it's a reflection about x-axis. How to find it? Simple. 1 minus 3i. You change the sign in between the x and y, okay? You are not going to change any signs here. Suppose you have minus here. That minus still here. Okay. Now you got that.
on the other side where the y value, x value.
Yeah, first works.
Okay.
If this is defined in here,
Yeah.
like this, then the conjugate is right here.
Okay. Yeah.
Yeah. Some people have this misunderstanding. If the complex number is here, conjugate can be here
Yeah,
too.
that's what I was wondering.
No, it's,
No, it's always down.
always about x-axis.
Okay.
Reflection, not y. Okay, that's good. Now, from here, we will try to find ZZ bar. ZZ bar, what I'm going to do is I'm just multiplying these two.
Oh, okay.
When I multiply these together, it's going to be 1 plus 3i. And here, 1 minus 3i. So if you do that, you can see 1 times 1, 1. It's going to be minus 3i. It's going to be plus 3i. It's going to be plus, so minus 9i squared, ne? Yeah. What is I squared? Minus 1. So that minus 1 with minus 1 gone. 9. So what is the answer? 10, ne?
Yeah.
These two go. So 10. Yeah. What if you try to get the square root of this one? That's obviously 10 square root.
Yeah.
Yeah. Why this is important? Get this one. Get this one, and then z. 1 plus 3i. Tell me what is z mod here? 1 squared plus 3 squared square root, right? It's going to be 1 plus 9 square root. What is that? 10. Ah.
Yeah.
Now we have a nice relation. So we can say, end of the day, z bar, z mod is equal to z bar square root.
Yeah.
Right? Now this is nothing, it's just knowing the fact only. Then when we have questions, these are just notations. That's why sometimes when you're in the middle, you don't understand.
Yeah.
Okay. So you found it. All good. So now you know how to deal with the arc and diagram. Right. Now let's think about this. Let z1 is equal to 1 plus 3i. C2 is equal to minus 1 plus 2i. Find z1 plus z2, z1 minus z2, z1 z2, z1 divided by z2. Okay, do that.